Get ready to witness a showcase of agricultural marvels that exemplify the epitome of innovation and efficiency. In this video, we unveil an extraordinary lineup of machines and tools that are revolutionizing the way we approach farming. Join us as we delve into the realm of autonomous robotic weeders that meticulously remove unwanted vegetation, smart irrigation controllers that optimize water usage, thermal imaging crop scouting drones that detect crop stress and diseases, variable rate seed drills that precisely plant seeds for optimal growth, and automated grain storage systems that ensure safe and organized storage. Together, they represent a new era of farming where productivity, sustainability, and technological advancements merge. Number 5. Autonomous robotic weeder. In the context of agriculture, the term autonomous robotic weeder refers to a specialized type of robot that is intended to find and eliminate weeds in agricultural fields without the assistance of a human operator. Autonomous robotic weeders use a variety of sensors and imaging technologies to detect and identify weeds amid crops. These technologies include cameras, computer vision, and hyperspectral imaging, among others. These sensors enable the robot to differentiate between plants that are wanted and plants that are not wanted. In order to move throughout the field without getting lost, robotic weeders use navigation systems like GPS and LiDAR, amongst other positioning technologies. The application of path planning algorithms allows for the determination of the most effective pathways for weed detection and removal, which in turn ensures that the entire field is covered completely. Weeds are pulled out of the ground manually by autonomous robotic weeders, which are outfitted with the necessary machinery. This may involve the use of mechanical blades, brushes, or targeted precision spraying for the application of herbicides. In order to eliminate or get rid of weeds, certain robots may employ non-chemical means, such as heat or electrical ways. Robotic weeders are engineered to remove weeds in a highly accurate and selective manner due to their specialized design. They are able to discern between crops and weeds, so causing the least amount of harm to the plants that are intended to be grown while successfully eradicating the unwanted plants. It's possible that autonomous robotic weeders will have machine learning algorithms and data analysis methods built into them. They are able to enhance the accuracy of weed detection over time as a result of this, because they are able to learn from the data acquired during operations and adjust their techniques for weed removal accordingly. Number 4. Smart irrigation controller. An advanced irrigation management device that makes use of technology and data to optimize water usage and improve irrigation efficiency is referred to as a smart irrigation controller. This type of controller is also sometimes referred to as a smart irrigation system, or simply a smart irrigation controller. Intelligent irrigation controllers change irrigation schedules and durations based on real-time weather data, such as temperature, humidity, rainfall, and evapotranspiration rates. This data may be found on the controllers. These controllers are able to avoid overwatering or irrigating during periods of rainfall by taking into consideration the present weather conditions. This results in water conservation and the promotion of more efficient irrigation practices. Some smart irrigation controllers incorporate moisture sensors for the soil or other types of environmental sensors in order to determine the real levels of moisture present in the ground. These sensors deliver information on the moisture content of the soil to the controller, which enables the latter to calculate when and how much to irrigate based on the unique requirements of the plants and the conditions of the soil. Intelligent irrigation controllers provide a variety of adjustable scheduling options and programmed options for the irrigation system. Users are able to create individualized irrigation schedules that take into account a variety of criteria, including the type of plant being grown, the type of soil, and the required amount of water. These controls make it possible to exercise pinpoint control over the beginning times, lengths of time, and frequencies of irrigation. There are a number of smart irrigation controllers that can be accessed and managed remotely through the use of web-based platforms or mobile applications. This provides users with the ability to monitor irrigation activities make adjustments to settings, and receive information about the state of the irrigation system or any system problems from any location. This makes management convenient and simple. Number 3. Thermal Imaging Crop Scouting Drone. The term Thermal Imaging Crop Scouting Drone refers to a specialized unmanned aerial vehicle, UAV, designed specifically for agricultural operations and equipped with thermal imaging technology. By recording thermal images of the fields, it may be used to monitor and evaluate the state of the crops and determine how healthy they are. Drones that do crop scouting using thermal imaging are equipped with cameras or sensors that can detect and record the infrared radiation that is generated by objects or surfaces. These cameras are able to detect fluctuations in temperature and produce thermal images, which are often referred to as thermograms. These images depict the heat signatures of crops and other things. Drones equipped with thermal imaging cameras for crop scouting can determine the crop's overall health by locating temperature irregularities and changes in the field. Variations in thermal patterns and temperature differentials can be used to detect diverse crop states such as water stress, nutrient deficiencies, disease infestations, or insect activity. Some examples of these conditions include water stress, nutrient deficiencies, disease infestations, and pest activity. The use of thermal imaging allows for the detection of anomalies or areas of stress in plants that might not be obvious to the human eye. Plants that are under stress or are afflicted with a disease may frequently have distinct temperature patterns in comparison to healthy plants. Farmers are able to pinpoint specific problem regions and take targeted action to solve the underlying issues by analyzing thermal photographs of their crops. Drones equipped with thermal imaging cameras make it possible to conduct rapid and large-scale crop monitoring and provide a picture of the fields from above. Farmers are able to efficiently cover broad areas with the help of this remote sensing capabilities, which also enables them to recognize possible issues at an earlier stage and make more informed decisions about irrigation, fertilization, pest management, or disease control. Number 2. Variable Rate Seed Drill. The term variable rate seed drill refers to a specialized agricultural instrument that is used for sowing seeds in a field and has the capability to alter the seed rate throughout different parts or zones of the field. The variable rate seed drill is also known as the variable rate seed drill. The variable rate technology, VRT, is utilized by variable rate seed drills in order to modify the seed rate dependent on particular criteria, such as soil conditions, the variability of the field, crop requirements, or production goals. This method enables exact control over seed location and density, which maximizes the potential yield while simultaneously minimizing the amount of seeds wasted. Precision seeding is made possible by variable rate seed drills, which allow the seeding rate to be adjusted while the machine is still operating. They have the ability to make automatic adjustments to the seed drop rate or spacing as the implement travels over the field. This ensures that the seed is placed consistently regardless of the varying soil types or yield zones. In many cases, variable rate seed drills are designed to interface with farm management software or systems, such as those that make use of field mapping and prescription maps. These maps indicate the desired seed rates for various portions or areas of the field, taking into consideration soil fertility maps, historical yield statistics, or any other information that may be pertinent. After that, the seed drill will use these maps to guide its automatic adjustment of the seed rate while it is working. There is the option to fit variable rate seed drills with section control mechanisms, which subdivide the implement into distinct working areas. Because of this, precise control can be exerted over which portions receive seed, hence reducing the amount of overlap and maximizing the efficiency of seed dispersal. Additionally, it gives the seed drill the ability to cut off or alter the seed rate automatically in regions that are not going to be seeded, such as headlands or overlapping passes. Number 1. Automated Grain Storage System. An automated grain storage system is a sophisticated system designed to automate the storage and management of grain in agricultural settings. This type of system is also known as an automated grain management system. It entails a variety of components and technologies that work together to enable grain storage that is both controlled and efficient. Sensors and other monitoring equipment are incorporated into automated grain storage systems in order to maintain a constant vigil over crucial factors such as temperature, humidity, moisture levels, and grain quality. These real-time data make it possible to exercise efficient control and management over the circumstances under which grain is stored. Automated grain storage systems typically contain climate control and ventilation systems within their architecture. These systems regulate the temperature, humidity, and ventilation within the storage facility to prevent grain from going bad, restrict the growth of mold, and keep the best storage conditions for various types of grain. Conveyors, elevators, and augers are all examples of automated grain handling equipment that are often included in these types of systems. These components make it possible for grain to be moved about within the storage facility, which in turn makes loading, unloading, and transfer processes more efficient. Automated grain storage systems sometimes include control or inventory management software as part of their setup in order to keep track of and account for grain supplies. These systems deliver precise information on the quantities of grain, as well as their locations and characteristics. As a result, farmers are able to make educated decisions regarding the storage, transportation, and sales of their grain.